Now next topic, potential due to an electric dipole. Now see, suppose we have the electric dipole as shown in the figure. Charge is plus q minus q separated by distance to a. This is the center of the dipole O, and from the center of the dipole point P, that is at position R. So this one is at position R. Now we want electric potential of this dipole at point P. Okay. So simple thing. First of all, we have to take potential at P due to plus Q charge, then potential at P due to minus Q charge. So from plus Q, the distance of P, that is R1, and from minus Q, the distance of P, that is R2. So for a point charge, we have the potential that is Q upon R. As per that, we can write V1 K, that is 1 upon 4 pi epsilon 0 Q upon R1, and V2, that is Q is negative, so minus 1 upon 4 pi epsilon 0 Q upon R2. So resultant potential at P, that is V1 plus V2. So we can write 1 upon 4 pi epsilon 0 Q upon R1 minus 1 upon 4 pi epsilon 0 Q upon R2. Now here if we take Q upon 4 pi epsilon 0 common, then we can write V, that is Q upon 4 pi epsilon 0 1 upon R1 minus 1 upon R2. But here we have the distance of that particular point, that is with respect to center of the dipole. So we have to represent this R1, R2 in terms of R. Okay. Now see here, suppose we consider this position R1 as a position vector R1. Then here A vector is like this, and this is our R vector. Okay. So if we take opposite vector of A like this, then we can write this is minus A. Okay. So that will be somewhere here, we can extend it up to this one. So we can say the angle between R and A, that is this one, and that will be 180 minus theta. And now we can say vector R1, that is this plus this. Okay, as per vector summation rule. So magnitude wise we can write R1 square, that is R square plus A square plus 2AR cos pi minus theta. Clear to all of you? Now similarly here, suppose we think about this R2, then vector R2, that is like this. This one is vector R. Okay. And if we take here, this one is vector A, then vector A plus R, that is vector R2 as per vector summation rule. So here angle between R and A, so you can extend this A from this one like this, so angle is theta. So you can write here, see R1 square cos pi minus theta, that is minus cos theta. This one is simplified. But now for R2 square, you can write R square plus A square plus 2AR cos theta. Okay. Now see here, take R square common. So R1 square equal to R square into 1 plus A square upon R square. Here 1 R is there, so minus 2A cos theta by R. Similarly here also, you can take R square common. So R2 square equal to R square into 1 plus A square upon R square plus 2A cos theta by R. Now R is very much greater than A. So we can neglect A square upon R square in both these equations. So we can write R1 square, that is nearly equal to R square into 1 minus 2a cos theta by r. Similarly here, neglect a square upon r square. So r2 square, that is r square, into 1 plus 2a cos theta by r. Clear up to this one? Now, take square root on both the side. So r1, that is r into 1 minus 2a cos theta by r raised to 1 by 2. Here also, r2, that is equal to r into 1 plus 2a cos theta by r raised to 1 by 2. We want 1 upon r1 and 1 upon r2. So take reciprocal of this one. So here 1 upon r1, that is 1 upon r, into this one 1 upon this raised to 1 by 2. So directly we can write 1 minus 2a cos theta by r raised to minus 1 by 2. Similarly, directly here also we can write 1 upon r2, that is 1 upon r into 1 plus 2a cos theta by r raised to minus 1 by 2. Now let's use binomial theorem, and then retaining term up to the first order and neglecting higher order terms. We know this thing. So we can write here 1 upon r1, this raised to minus 1 by 2, that will be in multiple with the second term. So 1, this minus 1 by 2 into minus plus 2 cancel. So a by r cos theta. Similarly here 1 upon r2, that is equal to 1 upon r into 1 minus a by r cos theta. Now we have 1 upon r1 and 1 upon r2. Now substitute these values of 1 upon r1 and 1 upon r2 in this equation 1. Okay. So we can write now here 1 upon, v equal to q upon 4 pi epsilon 0, 1 upon r into 1 plus a by r cos theta minus 1 upon r 1 minus a by r cos theta. Now if we take 1 by r common here, then we can write q upon 4 pi epsilon 0, 1 upon r, this 1 plus a by r cos theta minus 1 minus minus plus a by r cos theta. Now this 1 will be cancelled. A by r cos theta 2 times. So q upon 4 pi epsilon 0, 1 upon r, 2a cos theta upon r. But q into 2a, that is called the dipole moment P. So we can write V, that is equal to q upon 4 pi epsilon 0, 2a cos theta r into r square, and 2a into q, that is P, the dipole moment. So we can write 1 upon 4 pi epsilon 0 P cos theta upon r square. So here P cos theta, that you can write P dot r caret also, where r caret is the unit vector along the position vector OP, means center to the point where we are calculating the electric potential. In that direction you have the unit vector r caret, because this cos theta, here this theta is the angle between dipole moment and the position vector. So unit vector is in the direction of that position vector. Okay. So we can write potential at point P, that is 1 upon 4 pi epsilon 0 dipole moment vector P dot r caret upon r square. Here we consider this thing, r is very much greater than a. Now if theta, that is equal to 0 here, then potential will be 1 upon 4 pi epsilon 0 P upon r square. If your theta, that is pi, then cos pi minus 1, so V, that is minus 1 upon 4 pi epsilon 0 P upon r square. And if theta, that is equal to pi by 2, then V equal to 0. Theta equal to pi by 2, that is the point on the equatorial line. So on the equatorial line of electric dipole, at each and every point the electric potential, that will be equal to 0. Remember this thing, that is very useful for problem solving and MCQ solving. Now, here we have the electric potential at a point due to electric dipole. And here we can see this thing, the electric potential that not depend only on the distance r, but it also depends on the position of the point with respect to dipole, or we can say dipole moment, because here this cos theta appears. And here we can observe this thing, the electric potential of the dipole that decreases as 1 upon r square. And in previous theory we discussed this thing, the electric potential due to a point charge that decreases as 1 upon r. Clear? So this one is the electric potential due to dipole. Clear to all of you?